All right, welcome. Let's continue with our grind 75, and we're going to do merge intervals. Given an array of intervals where interval I is start end, so there's a two-element array, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So I don't, I can't imagine this question being asked by anybody but Amazon. Amazon pretty much asks like super easy ones that they expect you to know, and then they leave a lot less time for the coding portion. They might leave you like 15 to 20 minutes, as opposed to other companies that might give you the full hour and ask harder questions. But this is intervals are pretty classic. This is a fundamental question that I think sets the stage for a lot of sort of derivative type questions. So let's look at what we got. Vector of vectors. So that's how C++ is going to do it. I don't think we're going to have to import anything. So what the solution is going to end up kind of looking like. So we have to return a vector, and we're going to have to probably look at all of the interval entries at least once. So that means we're looking at an O of n runtime. And then either O of n or a constant space if you're not counting the inputs and outputs. But I think besides the inputs and outputs, it would be constant space. So let's look at what we got. A typical approach for this relies on the arrays being sorted by their beginning time. And it looks like all of these examples are, so 1, 4, 1. If sorting is needed, that's something to definitely clarify, because that affects the asymptotic runtime. Because if you have to sort them, that's O of n log n. If you don't, then that brings the runtime down to O of n. So that's a very important distinction. Make sure you verify if the inputs are sorted by their start time or not. So we're going to need to make our output vector of vectors, direction and magnitude. That's not what these are. These are just arrays. And then we're going to want to put the first interval into our output. So red dot push back. And then the first one. All right, so now we're going to step through and add it if there's an overlap. So what I like to do for interval type problems is to have a separate function for checking if there's an overlap, and I tend to use the same one over and over again, so I'll write it out first. So it's going to return an integer. In this problem, we only need to know if there is or isn't an overlap, but I like the integer to return the amount of the overlap too, because sometimes that matters, and that way I just have to remember one helper function as opposed to a few different formats of it. So overlap, and it's going to take two arguments. So vector int a, and then I guess it's going to do it by, we don't need to do a copy constructor. We can just do it by reference, so that's fine, because we're only checking and not modifying. So what it's going to do is it's going to return the maximum of their end times minus the minimum of their start times. And then, so let's see how that works. So return max A1 B1 minus min. Actually, it might be reversed. I might want the min of their end times. or, no wait, min of their start times. Okay, so let's reason through this. So let's take an example, these two, is checking if there's overlap here, and there should be. All right, so if there's overlap, so 1 and 3 is A, 2 and 6 is B. So the max of their ends, so max of 3 and 6, so we're going to have 6. Oh, no, okay, so maybe we want their beginnings. So max of their, so 6 minus 1, so 6 minus 1. That's not correct. Okay, so let's do the max of their starts. So if we have the max of their starts, we're going to have 2. Okay, we want the min of their. Goodness gracious. Okay, we want to end up with 2 minus 3. So we want the max of their starts. Okay, yeah. Max of their starts minus the min of their ending times. All right, so max of 1 and 2, so 2 minus the min of 3 and 6, so 3. 2 minus 3, that's going to be minus 1, so there's a little bit of overlap there. Okay, that's what we want. So what happens? We've got this overlap function. Let's move that outside of the main function, actually. Okay, that's better. So we've got this, and so now we want to step through. So for I equals 1, and I'm going to need another temporary variable. I'm just going to call it cross for how much they cross. It doesn't super matter. And then as long as I is less than the length of the intervals. And then we'll increment I at each step. So this is not the most common way of declaring a for loop. Basically, so this first part is declaring variables. The second thing is a condition that it'll check at each iteration, and then what it does at the end of each iteration. So since we're declaring variables, we can declare this cross here, and it'll go out of scope after the for loop. We can declare it outside too, or do some kind of other braces scheme if we wanted to go out, but this is fine too. Anyway, so we're going to check how much overlap there is. Cross is overlap. So the two things we want is the last interval of our output, because we want to check if we want to extend it or add another one to the output. But if there's no overlap, we'll add another one. If there is overlap, we'll extend the last one. So overlap, the back is how you reference it. And interval is I. So if there's some overlap, we're going to have a minus 1. Actually, if they're touching at 0, then we'll count that as an overlap as well. Yeah. So if it's less than or equal to 0, there's overlap. So we want to extend our last item. So return dot back. End item equals the max of itself, or the excuse me, or the interval we're considering. Okay, so then if if there is no overlap, we want to do something else. We want to push the current interval onto our output. And then what else do we need? We need to return the output, of course. Is anything missing? I don't think so. So let's step through an example. Let's go with the example 1. I'll do example 2 first because it's smaller. All right. So first, we declare our output vector. We push 0 onto our stack output. It's not a stack, it's a vector, but you could use it as a temporary stack. So 1, 4. Okay, so push it on. 4 I equals 1. So starting at the second one, we find our overlap function. So our overlap is going to be between 1 and 4, 4 and 5. Well, the max of 1 and 4 is 4, minus the min of 4 and 5 is 4, so 4 minus 4 is 0. We have it, so we return 0. And then, so cross is 0. If cross is less than or equal to 0, we declared an overlap. And we're going to take the back item, so this 4 is going to be equal to the max of 4, or the ending of our next one, so 5. So it's going to become 5. And then, and that's it. That was the last step. So then we return 1, 5. And that's our expected example. I guess I'll do a longer one and maybe go through it a little faster. All right, so what do we got? We got this. All right, similar thing, declare, push the first one on, so 1, 3. All right, so next iteration, we started with 2, 6 at the start of the loop, overlap. So we're gonna have 1, 3 overlapping with 2, 6. So we're gonna have the max of the max of 1 and 2, so 2, minus the min of 3 and 6. So 2 minus 3 is minus 1. We're going to return minus 1. And that is less than or equal to 0. So we declare an overlap. So we're going to take 3 is equal to the max of 3 or 6. So it's going to become 6. Okay, and then next iteration. Now we're considering 1, 6, and 8 and 10. Overlap there, so the max of 1 and 8, so 8 minus the min of 6 and 10, so 8 minus 6. There is no overlap because that's going to be 2. We're going to return 0, so cross is 2. That is greater than or equal to, so that's greater than 0, so we're going to push 8, 10 onto our output. Okay, next iteration, 15 and 18. All right, so we're going to check overlap. So we're looking at 8 and 10 versus 15 and 18. Max of 8 and 15, so 15 minus the min of 10 and 18. So 15 minus 18, 15 minus 10, that's going to be 5. We return 5, so cross is 5. That's greater than 0, so we're going to push this onto our output again. So 15... 18. And then that's our last one. So we're going to break out the loop and we're going to return this. So we got 1, 6, 8, 10, 15, 18. That is our expected output. So let's talk about time and space complexity. Well, we already kind of did. So we're going through each of the intervals once. And we're doing this overlap, which is constant time, constant time. We're doing constant time operations for each of the intervals. So we're looking at O of n time. O of n time. And then for space, it's going to be space if the outputs and inputs are not considered. For the output. Yeah, so I like to, especially like a little bit of time complexity stuff, I like to write that in comments at the bottom, particularly so you're not counting on the interviewer's memory, so that after the interview they're not trying to remember exactly what you talked about or what important points you touched on. They do like to see things like helper functions. They like to see type declarations and that sort of thing. Obviously, getting it correct is the most important thing of all, but it's not. It's necessary, but not sufficient. Anyway, so let's give it a run, see if there's any syntax errors. Accepted. Check the other test case. Okay, good. Oh no, what did I miss? Intervals 1, 4, 0, 4, output 1, 4. Oh my goodness. All right, so when I was talking about potentially sorting, so it looks like some of the inputs are in unsorted order according to the starting position. So we are going to have to do that, and it is going to make the runtime worse. And there's not really a better way to do that because this does rely on them being in sorted order. Otherwise, if you don't sort them, then you might be looking at like an O of n squared runtime, looking for each, whatever the next one was, each time, you know, at each step, and that's just, it's just sort it, get it out of the way. So sort. I don't know why C++ makes you write out begin and end instead of just like sort intervals, but whatever. So that's going to be n time for sorting, which dominates. Oops. Goodness. Of hit. Goodness gracious, new keyboard. Anyway, so let's try that. Okay, yeah, that was it. All right, so these don't matter, but marking off our to-do list does. So merge intervals. Thanks.